Hello everyone, welcome to my channel Middleware Technologies. Today we are going to understand about Dragonflow system, what is Dragonflow and how this peer-to-peer distribution system works. So Dragonflow is an open source peer-to-peer based file distribution system. It is basically like a BitTorrent application wherein it helps in distributing the files in an efficient and faster manner. And it can be used in the following scenarios like application distribution, cache distribution, log distribution, and container image distribution. So let us try to understand what is the workflow that carries out when a request for a file gets triggered. So here is the high-level diagram of the Dragonfly system that gets deployed onto a network, which helps in the peer-to-peer distribution to happen. So let us assume we have a Kubernetes cluster wherein we have multiple worker nodes on which there are applications running, and these applications rely on the images that gets downloaded onto that worker nodes. So these are the images that we need to distribute onto the multiple nodes in an efficient and faster manners to increase the performance and efficiency. So this is the high level diagram. Let us try to understand what happens in this flow. So first of all, let us try to understand what are the important components of a Dragonfly peer-to-peer distribution system. So we have a manager, we have a scheduler, we have a seed peer, and we have peer nodes. So these nodes peer or the seed peer nodes are like worker nodes on which we will download the file or the image which we need for running the application. And manager is the overall cluster manager which holds the configuration for the cluster, how the Dragonfly P2P distribution needs to be working, what is the rate of download needs to be happening, and all those configuration will be carried out in this manager console. Scheduler is where the peers will try to reach out in order to understand whether it is a first time download or whether we need to download it from the source, and what are the seed peer and the peer nodes available in the network. So let us try to understand the request flow, what exactly happens when a request for a new image is happening on a Kubernetes cluster of worker nodes. So let us go into the process. So the first step, that is request initiation. So this is where the request is coming from the client, which is in this case is going to be the container runtime, which initiates a request for downloading a container image, and this request is proxied through the Dragonflow HTTP proxy, and it goes to the manager. So basically the request first goes to the manager to help get to know the information on the schedulers that are available in the system. So once it gets the information related to the scheduler, the request is then rerouted to the discovered scheduler. So this is where the initial request gets routed. So now let us go to the next step that happens, that is task registration. So once the request has identified the scheduler in the peer-to-peer network, it goes to that scheduler and tries to see it registers a task. So this task is basically in order to contains the metadata about the file and the size of the data and the hash, and from where it is going to be downloaded. So this information is registered as a task, and now this task needs to be assigned to some node wherein the download will happen. But in this peer-to-peer network, the download happens based on whether the file has been already available in the network or whether it is a first time download. So the first thing, that is peer discovery. The scheduler checks if other peers in the network already have parts of the requested file. So this is very important. So in a peer-to-peer network, the first step it is to identify if the page or the nodes that are available in the network already have that file or the container image downloaded. If that is the case, the peer that is not having that file will get that file in the form of chunks from multiple peer nodes where it is available. So this is this is the case wherein the file is already available. It uses a distributed hash table. So basically it has a distributed hash table which helps it to identify which page have the files and which page do not have, which page are requesting for a file from the network. Now let us try to understand the peer-to-peer download. So if this is where if other peers have parts of the file, so the file is available in the network, the scheduler directs the requesting peer or the peer that does not have that file or the chunks of those files, it asks that peer to download those parts directly from the page wherein it is available. This is the core part of the Dragonfly peer-to-peer distribution. So this basically improves the performance and efficiency. Rather than downloading it from the source, which can be available at a remote destination, it is going to download from a local network wherein it is already available in the form of chunks. The file is divided into smaller chunks called pieces, and the page download these pieces from multiple sources simultaneously. So it is not like it is going to download the complete file from a particular pair, but it is going to take all the pairs into consideration and it is going to download. So let's say from this diagram, so let's say this pair is not having that file, but these two pairs in that cluster like are having that file in the form of chunks. So those chunks will be downloaded to this pair node in the form of smaller chunks, and they will be rearranged once the complete file is been downloaded. So this is the case in which the file is already available. But let's say if the file is not available, so that is the case in which the seed pair comes into picture. So if no pair has the file or the specified piece, the scheduler designates a seed pair. The seed pair is responsible for downloading the file from original source. So the scheduler identifies whether the pairs have part of the file or the complete file already available in the nodes. If available, they will be used. Otherwise, the seed pair is going to identify the scheduler is going to identify the seed pair, like fetch the seed pair in the network. Like there will be one node that will be assigned this role of seed pair. So it will talk to that seed pair and it will ask to trigger the seed pair, which is basically downloading the source file. So the seed pair is going to trigger the download from the source, and it will download in the complete file in the form of chunks. So once the seed pair has downloaded a piece, that piece is it becomes a source for other pairs to download that piece. So basically, once the seed pair has that piece of the file, that gets distributed to the other pairs in the form of chunks. Now let us understand the data exchange and verification. So pairs exchange data chunks with each other using BitTorrent-like protocol. So as I said, like the Dragonfly peer-to-peer distribution is basically similar to what the BitTorrent system works, and each piece, like whatever the part of the file that is getting downloaded from the nodes or the seed pair, it gets verified using its hash to ensure that the data has not been corrupted. So it ensures the data integrity once all the pieces have been downloaded from the pairs. It will verify its integrity and rearrange it as a complete file. So the last step is download completion. So as I said, once the peer has downloaded all the pieces, it assembles them to reconstruct the complete file. The peer can then become a source for other peers. So now this peer has the complete file, and this peer can act as a seed for other peers wherein the file is not available. So it can distribute this file within the network. So this is how the Dragonfly peer-to-peer distribution system works. So this is how the Dragonfly peer-to-peer distribution works. So we have understood about the important components in this workflow. We have talked about the manager, scheduler, seed peer, and the peer nodes, and we have understood what is the request flow, how it happens for a new file request or the new image request, and for a file that is already available in the network. So as I said, these are the important components in the Dragonfly system. The manager provides overall configuration, communication between different components in this cluster. The scheduler manages the download tasks, schedules speeds, and optimizes download efficiency. Seed peer basically is a primary node, we can say, wherein the download happens from the source, and the peer is the nodes in the system wherein the download and upload of the file takes place in the form of pieces or chunks from the other pairs. So what benefits do we get from the Dragonfly distributed peer-to-peer system? It increases the download speed. So instead of downloading it from the source, wherein it can download the file from the network of peers in the form of chunks, and allowing the load to be distributed onto all the pairs. It reduces the bandwidth of consumption. So instead of all the requests going onto a particular source and making it load, take all the load, it will distribute the load into all the pieces, so that the bandwidth that is used to download from the source is available, and it can be used for other purpose. It improves availability even if the original source. So let's say in this diagram, so let's say the source got unavailable for some reason. The file is still available on the other piece, and it can be distributed to the other pair nodes wherein it is not available, making it highly available. And it is fault tolerant. If some pair fails, downloads can continue from other available fields. So let's say if some pair gets unavailable for some reason, the other pairs, the pairs can download from the other pair nodes about the same file instead of waiting for that pair to become available. So that is how the fault tolerant feature is provided by this Dragonfly system. So Dragonfly is a powerful tool for efficient and reliable large-scale file distribution. So it is particularly used in a cloud-native environment and container image management, and it can be used in Git repositories also for large file distribution. So these are some use cases wherein the Dragonfly system can be utilized. So this is all I wanted to tell you about the Dragonfly system, like how it works and how it is similar to the BitTorrent protocol, which we widely use in order to distribute the files. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video. You guys have a great day.